So in chapter 5, we're going to cover 5.1, 5.2. We're not going to do 5.3. We're going to do 5.4 and 5.5. And I don't know if there's any more sections or not, but those are the ones we're going to cover. Okay, so in 5.1, we're going to talk about linear equations in two variables. These are linear equations, and so we're familiar with linear equations. We have forms for those. We're kind of used to graphing linear equations and using y equals mx plus b. Now we'll see that form sometimes, but we're not going to do a lot of graphing. And we're going to see them in another form. We'll talk about that in a minute. But let's look at this example here. We have a graph, and these are symptoms of physical illness among college students. So are they getting sick or not? How many symptoms of sickness are they getting? And then on the average. And then we have two groups of students. We have the procrastinators and the non-procrastinators. So at the beginning of this semester, it looks like the non-procrastinators are having a little more illness than the procrastinators. I guess the procrastinators aren't worried because they're going to put it off. Okay. But by the end of this semester, the procrastinators are getting sicker than the non-procrastinators. Okay. So these are both linear equations, and there's two of them. This line for non-procrastinators, it has a slope and a y-intercept. This line has a different slope and a different y-intercept for the procrastinators. Okay, so we have two lines that we're talking about. It turns out in this example that the two lines actually cross right there. So at that point right there, both the procrastinators and the non-procrastinators have the same input and output. So it looks like it is at about week 6, and they're both averaging about, I don't know, maybe 3.5 symptoms on average. Okay, so this is the type of idea that we're looking at, not just one equation. Each equation has an infinite number of solutions, but we're looking at the two equations together and what points satisfy both equations. Okay, so we have an example here, so I want to talk a little bit about the notation. First of all, notice the form that these equations are written in. It's in this form, ax plus by equals c. So the constant is on the right, and then you have the x term plus the y term. Okay, so they're written that way. If a and b and c are fractions, you can clear the fractions, so that would be helpful to have integers there. So that might happen in an example. Also, we have this brace here. This says that the two equations, we're going to look at them together. That's our system. That's why it's called a system of equations, because we have two of them. All right, they're both linear equations, and they both have two variables. Okay, so we're looking at it in a plane, like graphing in a plane, like in an XY coordinate system in the past. And we could actually graph both those lines. You could come up with a table of values, or you could put it in slope-intercept form, and you could graph that line. Let's go ahead and do that. So if we write it in slope-intercept form, it looks like this. So 1, 2, 3, 4, 5, 6, 7. It's going through that point. And then it has a slope of -1. So it's going something like that. Okay, not very accurate. Okay, in the other line, we could also graph that. You have -y equals -x minus 1, or y equals x plus 1. So the y-intercept is 1. This is good review for the final. You should be able to graph a linear equation. The slope is 1, so up 1 and over 1. And so it goes like this. So you can see the two lines visually if you graph them. Now, this is a method for solving, but we're not going to spend a lot of time with this method, other than this example I'm showing you, because it's inaccurate. If your line's off a little bit or your ruler's not quite lined up, you're going to get different answers. And then how would you read answers like, 3 2/5 or something? You're not going to be able to read that off the graph. Okay. So we're looking for solutions as one solution in this case, this point right here, that's both true, it's both on the bottom line and the top line, okay? So it satisfies both equations, and that's what we're looking for, and that's what this study is in 5.1. We're going to show you a couple methods for doing that. There's actually several methods, but we're really only going to look at two methods. Okay, you could think of lots of things that add up to be 7, right? 1 and 6, 2 and 5, 3 and 4, 6 and a half and a half. See, they don't have to be integers. All of these are ordered pairs, a combination of x and y. But then you could look at the bottom equation and see if it works. So 1 minus 6, is that -1? No, so it's not that one. And you could go through them, but this would take forever. It turns out, though, that ordered pair actually works. In the bottom equation, you have 3 minus 4, and that does equal -1. So we don't really have a method called just guessing and checking, but we should know how to check our answer. And the thing is, your combination, your ordered pair, has to work not only in the top equation, but also in the bottom equation. So if you have two equations, it's got to work in both of them. All right, we're going to show you the method for solving a system of equations in the next video.